We are now ready for part 4. That's lesson 2.8, U.S. traditional multiplication. We're going to be able to use U.S. traditional multiplication to multiply multi-digit numbers. We're also going to be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. Algorithm is a word that we need to review real quick. It's a set of step-by-step instructions for doing something, such as carrying out a computation or solving a problem. Here is a story problem for us to look at for our math message. A typical cat sleeps up to 18 hours per day. Wow, that sounds nice. There are 365 days in 1 year. How many hours does a typical cat sleep in 1 year? Pause the video and try this out. How many hours does a cat sleep in 1 year? All right, so you can see my work over here to the left. I took 365 times 18. Remember, though, what we can do before that is round, do some estimating. So I'm going to take 350 times 20. And I know that 335 times 2 is 70. And then I would need to add on those 2 zeros, making it 7,000. So I'm going to compare. And those two numbers are pretty close to each other. So I know that my multiplication is most likely correct. What could I do to check it again? Yeah, I could do lattice. I could do partial product as a way to keep checking my work as I am practicing my U.S. traditional. So moving on, remember U.S. traditional multiplication is an example of an algorithm, or that set of steps that can be used to solve a certain kind of problem. So today we're going to extend our U.S. traditional multiplication to multiplication of larger numbers. Yesterday we did 2 by 2, or last lesson we did 2 by 2. Now we're going to work with even larger. Here's an example, 506 times 43. So we're going to take a look at this. And what we have here is on the left-hand side is we have partial product method, 506 times 43. You can see we're starting off here. What we have is taking 6 times 3 is 18, 3 times 0 is 0, and then 5 times 3, or 500 times 3, is 1,500. And we had to write all that out. And if we look at the U.S. traditional side, this right side of the screen, we're doing the exact same thing, except the difference is we've taken up 3 lines of work for what we did in 1 line with the U.S. traditional. Okay? So continuing to compare these strategies, partial products over to the left. So we left off with the 1,500 or the 1,500. Now we moved over to 40 times 6, which was 240. 40 times 0 was 0. And then 40 times 500, we got 20,000. So we got 20240. Well, if we look over at the U.S. traditional, we think about what is the value of the 4 and the 43, and we think about how it is worth 40. So we're actually taking 506 times 40, and we can see that we've carried our 2 up here, and we've still got 20,240. We got the exact same thing, except this time we've only used up 2 lines with all of our work versus 1, 2, 3, 4, 5, 6 lines. Look how long this is. We've got lines that have 0 in it. Just takes up so much more space. Still works. Partial product still works. It's just when we look at the 2 strategies, the amount of work written out for the partial product side and the amount of space on the U.S. traditional. U.S. traditional is doing the exact same thing, except it's a lot more efficient. Okay, we take a look. We still get the 21,758. But look at that. So solving 457, my apologies, 457 times 309. Go ahead and try that out. Try doing it partial product and then US traditional. It's a great way to check your work, but also to compare the strategies. Let's take a look at that. Take a look at the work on the left side. That's the partial product side. We've got 7 times 9, 50 times 9, 400 times 9. Then we've got, they didn't put the zeros. They could have. If they did, it would have looked like this. 0, 0, 0. Then they did 300 times 7, 300 times 50, 300 times 400. And they got 14,100, or 141,213. Now still, they got that here. They just didn't include the zeros. Over here, we included the zeros. Even when they included the zeros on the US traditional and they didn't on the partial product, you can still see it. It was a more efficient, more put together strategy. Still doing the exact same thing. Okay, today we're just comparing the two. So again, 417 times 99. I want you to pause the video, do 417 times 99. I want you to do it partial product, and I want you to do it US traditional. You could even do it lattice. Do 3 different methods. Compare all 3 of them and compare the amount of time and the amount of work for each one and see which one is more efficient. Again, pause now and then come back and check. So we're just comparing the 417 times 99 as partial and as US. This is checking your work. Same thing as I've said before. We still get the exact same answer, but the US traditional is just in a nice, neater package. 41,283. So open up your journals to page 56. We got a couple pages or a few problems to practice here. And I'm going to do one of these with you. Notice on page 56, we still have estimating. Estimating is still a great way to start off your multiplication, no matter what method you use, no matter which algorithm, because it allows us to make sure that our answers make sense, make sure they're logical, make sure they're reasonable. Let's do number 3 together. Okay. Number 3 says 72 times 110. I'm going to rewrite it. And we've talked about this before. When you're multiplying, it doesn't matter what order. It's just like when you're adding. So I'm going to actually put my larger number on top. So I'm going to change it to 110 times 72. And this, they want us to use US traditional. So I'm going to do US traditional. I'm going to start in my ones. I'm going to take 0 times 2. I know that's 0. 2 times 1 is 2. And then again, 2 times 1 is 2. So we know 110 times 2 is 220. I'm going to change my color for moving over. I know that my 7 is actually worth 70. And I'm moving over to the tens place. So I'm just going to go ahead and put a 0 in that ones place there to remind me I don't need anything there. So now I'm going to do 7 times 0, which is 0. And then 7 times 1, both times is 7. So 110 times 70 is 7,700. And remember now, we're going to add these two together. So that's a 0, 2, 9, and 7. The answer is 7,920. I forgot to do something. What did I forget to do? All right, I forgot to estimate. So I'm going to do my estimation here. I'm going to do 70, and I'm just going to do times 100. 70 times 100 is a good estimate for this because 72 can round down to 70 and 110 can round down to 100, giving me 7,000 as an estimate. And I want to keep in mind that I rounded both of these down. I took that down, I took that down. So this is going to be smaller. But look, they're both 7,000. Okay? Now I could take 110 times 72 and I could do it as lattice as well to check my work. Because remember, I want to check. I want to get in the habit of checking my work often just to make sure I'm correct. So I'm drawing a 3x2 lattice box. Could I do partial products to check? Definitely. I'm just showing you a different way. Sorry, these lines are so squiggly. So I'm going to do 110 times 72. And I'll change the color here so we can see that better. So these should be zeros because anything times 0 is 0. And then we've got our 7 over here because 7 times 1. And again, 7 times 1. And then 1 times 2. And then 1 times 2. So we've got a 0 here, 2 here. 0 plus 7 plus 2 is 9. And then 0 plus 7. And we've got 0. So we've got 0, 7, 9, 2, 0, 7, 9, 2, 0. Okay. So that is a great way, to check your work. Your turn now. I want you to do 1, 2, 4, and let it load. 5, 6, and 7. But let's take a look at 5 and 6 first. These are story problems versus just the multiplication problems. Number 1, a clerk ordered 72 boxes of paper clips. There are 250 paper clips in each box. How many paper clips are there in all? So don't forget, when you are doing story problems, the best way to start these off is to use cubes. Circle your numbers, underline your question so you know what you're supposed to do, box in important words, evaluate your work, and solve. Okay? And then 6, a photo of a building is 18 centimeters tall. The real building is 892 times as tall. How tall is that building? And then 7, what strategy did you use to solve problem number 3? Explain your strategy. So again, up here on number 3, which we did together, what was that strategy? How did we solve that? So pause the video now, then come back and check your work. Okay, 1, 2, 3, and 4, your answers are here. We have our estimates for each one. Remember, that should be your first step. For number 1, we get 21,318. Number 2, 1,184. Number 3 was the 7,920 that we did together. And then number 4, 28,340. Number 5, the 72 boxes of 250 paper clips was a total of 18,000 paper clips. You can see the estimate was 21,000. 18,000 is logical. It's reasonable. It makes sense. And 18 centimeters picture, but the real thing was 892 times taller. Well, we could estimate 20 times 900, getting 18,000. In reality, it was 16,056 centimeters. And finally, the sample answer for that strategy would be, maybe you did partial products. Maybe you did lattice. That's what we did. We did traditional, and then we used lattice to check our work for this one when we did it together. So that is the end of part 4 of U.S. traditional multiplication. And just like in lesson 2.7, home link 2.8 is another great review for choosing multiplication strategies. You can see that we've got basic multiplication problems, and then we've got a couple more word problems, and then more powers of 10 practice at the bottom. These home links are always great to review what you've been practicing. That way, if you have questions, you can use these to also get more help and more review. Again, today we were using U.S. traditional multiplication to multiply multi-digit numbers. We were also performing operations with multi-digit whole numbers and with the decimals to the hundredths. Now you may head on over to your math Canvas course and work on your independent work.